Okay, I had a few questions about specifically 9 and 10 and 11, so I thought I would record a little video for you to go back over and watch it this weekend when you have a little bit more time, and you can play it over and over if you're still struggling to get it. Number 8, we were just asked to reverse the relationship to show the table on the right as the inverse relation to the table on the left. So you just switch places with your X and your Y, or your input and your output. And then number 9, I think the confusion, well, I know for me, the confusion came in here. They're asking, can the relationship in question 5, that is a typo. That should be question 8. So can the inverse relationship in question 8, which is the one we just found, can that be modeled by a linear function? So that's the question we need to ask ourselves. And the answer is yes, it can. The way we know that it can is because if we take, it's a constant rate of change. The rate of change stays the same from one point to the next to the next. So if we use that slope formula, y2 minus y1 over x2 minus x1, we're going to get the same thing each time. It's going to be a constant rate of change. So if we 2 minus 1 over $10.14, 2 minus 1 over $10.14 minus $10.07 is the same as 3 minus 2 over 1021 minus 1014 is the same as 4 minus 3 over 1028 minus 1021. So the answer to question number 9 is yes, it can be, because the rate of change, and I abbreviate that ROC, remains constant. Remains the same. And that rate of change, we need to find it here to do problem number 10. So all we need to do is use one of those slope features or slope formulas to find the rate of change. So I'm going to use these 2 points here. Actually, no, that'll make it. Let's use these 2. So what's the rate of change here? So we're going to say 1 minus 0, difference in your y's, over difference in your x's, 1007 minus 10. So that gives us 1 over 0.07. Now, it's very awkward to have fractions with decimals in them. So in order to clear up those decimals, we're going to multiply both the top and the bottom by 100. We're actually just multiplying by 1. Actually, we're multiplying by 100 over 100. But what we're really doing is we're multiplying that fraction by 1. And you can multiply anything by 1 and not change its value. So then that gives us a rate of change of 100 over 7. So that's our rate of change. That's our slope. Rate of change is the same thing as slope. And in algebra, we use the letter M to represent slope. So now we want to find the y-intercept of that inverse relation. To do that, we first have to find the slope. Then we take that slope we found and we take any point in our equation. I'm just going to take this point. The 0 point is always easiest to work with. Either the x or the y-intercept is always easiest to work with. So now we're going to take that point and substitute it back into the y equals mx plus b form. Except in place of y, we're going to put 0. In place of our slope, we're going to put 100. And then in place of x, we're going to put 10 plus b. That's what we don't know, so we're trying to solve for that b. So then we end up with 0 equals 1,000 over 7 plus b. Again, we're still trying to solve for that b. So we're going to subtract 1,000 over 7 from both sides. And we get b equals negative 1,000 over 7. So now that we have a value for b and we have a value for m, we can write the function in slope-intercept form. So we're going to use y equals m x plus b. b is a negative, so it's just going to end up being minus b. 100x, 100 over 7x minus 1,000 over 7. And that is our inverse function for the function given in the table on the left. Hope this is helpful.